get rolling here in a second. Ryan, I don't know if you got any housekeeping details you want to
The only thing I want to mention is, because people will be listening to this recording later, if you are listening to this recording, it is in fact part 2, as Doug just said. So please go back and watch part 1 first. tecmungo.com/training. You can find all the videos there. Watch part 1 and then watch this one. But other than that, everybody that's on the live call right now, we welcome you. We got a lot of stuff to cover, so I'm going to stop blabbering and let Doug drive.
All right, guys, again, good afternoon. And what we're going to pick up today is let's go through the component overview, and we'll go through each and every component of the system. Once we get through that, then we'll get into the actual phone app setup and how it integrates into the Bluetooth module of the outdoor unit, and take you through that and the troubleshooting and the startup and software update portions of the phone app. So kind of a quick look as far as new components with this new system. We're still going to have an inverter, which is going to drive the compressor and the condenser fan ECM motor. We're going to have the rotary compressors on the 2 through 4 ton. We're going to have a scroll compressor on the 5 ton. Okay, so these are all new. These are Samsung compressors. ECM fan motor, which is very similar to what we had on the VNA and the ANVs. EXV, we did add an EXV, and as we go through component familiarization, I'll show you where the new EXV is. The big one is the Bluetooth module. This is, I think you're going to like this. So this is what you're going to communicate with your smartphone outdoors. And then the 5-ton unit, of course, we're going to have vapor injection, which is really a braze plate heat exchanger, and its function primarily is for subcooling of the liquid prior to it entering the liquid line and on to the evaporator coil. So first thing let's take a look at is the difference on the 5-ton unit versus the 2, 3, and 4. And the primary difference, as you saw, is one, we're using a scroll compressor, but the biggest thing on the 5-ton is the braze plate heat exchanger, which is this device right here. So as we talk about this, I don't want you to think that that's something that you have to do any additional piping on. This is part of the package. It's part of the condenser, part of the heat pump package. So, and only on the 5-ton unit, okay? Now, I talked briefly about it yesterday. I talked about the liquid line filter dryer having to be located out at the outdoor unit on the 5-ton unit. And of course, mentioning the braze plate heat exchanger, this is what we're talking about right here. And then I'll get into more detail in a second on that, okay? On the 5-ton units, you're gonna have 2 EXVs. One if you have a heat pump, and then secondly, you'll have the second EXV, or electronic expansion valve, if you will, for the braze plate heat exchanger. Again, 5-ton unit only, okay? The 2, 3, and 4 will not have the braze plate heat exchanger. So we had to add that to the 5-ton, and that's for kind of increased, enhanced capacity at high outdoor ambient temperatures. So for the most part, this thing really won't even come into play in the greater TEC Chicago market, because we're not going to be up to 120-degree outdoor ambient temperatures. So now, again, as we talked yesterday, if we have an installation where these things are in parking garages or in some type of building within a building, you may see condenser temperatures approach that high, and then that's where this will kick in and actually function and subcool the liquid. Okay. How this thing works, so if we look at the compressor, we look at the refrigeration cycle, so obviously we're taking hot gas off the compressor, going into the condenser coil, going through the condenser coil subcooling circuit. Then typically we go into our liquid line, which we still do, but what we also do is take some of that liquid off and we go into the second EXV. And of course, we create the pressure drop, And then we go into the Braze plate heat exchanger, which now this is almost acting like an evaporator on this side, where we're removing heat from the heat exchanger. And we take that superheated refrigerant gas back and we inject that about midpoint of the scroll flanks. So we've got this operating whenever we're in that high ambient, outdoor ambient temperature. So by this cycle right here, we're dropping temperature in the Braze plate heat exchanger, which in turn is actually cooling or subcooling the liquid refrigerant going out to the evaporator. Okay, so when you pipe these units in, you're still only going to hook to a suction pipe service valve and a liquid line service valve. So this is all internal to the unit, but that's what this is doing. This refrigerant circuit right here is simply subcooling the liquid, leaving the unit, going to the evaporator. And again, this EXV only comes into play and operates when we have high outdoor ambience. And this unit's looking at head pressure, it's looking at saturated condensing temperature, it's looking at all kinds of different things like that and determining when it needs to go into this function or operation on the 5-ton machine only. Okay, so you may have one of these 5-ton units and have this, and you may never see this come into operation around here, in our neck of the woods. So, but anyway, if you get a 5-ton, you look in here and you see that, that's what it is, that's what it does. And again, just a little bit more explanation on this. This is controlled by the Pcm module or primary control module. And it's going to look at a lot of things. It's, again, saturated condensing temperatures. It's going to look at the transducers on the condenser side and look at head pressure. It's going to look at suction pressures. And all these things are going to be used to position the EXVs and allow that Braze plate heat exchanger to operate. Okay, so your PCM, we're going to look at that just like, again, like I said earlier, or in yesterday's part of the program, the PCM is basically the same thing as the AOC board on the previous models. Okay, so we had the AOC board, which was basically the brains of the unit, and we had the MOC board, which controlled the speed of the compressor and the condenser fan. All right. Now these EXVs, and both the EXVs, if you have a 5-ton unit on the Braze plate heat exchanger, and then if you have the heat pump, that EXV, both are going to be a stepper motor type EXV with 475 steps from full open to full closed. For service information, the windings on these EXVs, when you ohm them out to the common leg, you're going to see 43 to 49 ohms per leg. And you'll have 4 different readings to take. You'll have 4 different windings. So again, 43 to 49 ohms to the common leg and troubleshooting the EXV stepper motor itself. So you should have that resistance. It shouldn't be shorted or open. You should be within that range, 43 to 49. Okay. And then for you techie guys that are into the EXVs, again, 475 steps from full open to full closed. If you have an EXV on the 2, 3, and 4, and 5-ton units for heating operation, the way they work is just like the old VNAs and ANVs. It's the same thing. In the cooling operation, the EXV steps wide open, so 475 steps to full open, wide open position. Defrost operation, of course, will be full open because our defrost operation is essentially the cooling mode. In the heating mode, you'll have a position that sets up that could be about 10% open at initial startup in the heating cycle. And then that EXV will throttle open and closed, trying to maintain 10 to 12 degrees superheat in the outdoor coil in the heating heat pump mode. Okay, other than that, the cooling mode, it always goes wide open. After the cooling cycle, the EXV will go full closed. So it works just like it did before in the VNAs and the ANVs. Okay. So I'm going to stop at this point, Ryan, just for some quick questions on this, what we call vapor injection, or this Braze plate heat exchanger, because this is brand new to the residential field. So any questions on this before we move on?
We have not got any questions on that yet, but John did ask a question, I can't even pronounce, asking if the unit is only accessible from the top.
You've got some access from the side panel. Basically, the cabinet is like the VNAs and the A and Vs. It's basically the same type of cabinet. So you have some side access to service all the components. But if you get into a major repair, you will have to take the control panel assembly off and out of the way. So hopefully that answers John's question.
Yep. And the other question, Andrew asked if this was AC or DC voltage.
Well, the power supply to the unit, of course, is going to be AC single phase, 220, 230, 240, whatever you want to call it. As far as if you're asking a question on the EXV, that's going to be DC 12 volts. The inverter that drives the compressor, essentially it's like a VFD, so it's the same thing. It's going to disassemble the AC power and reassemble it. It's going to be basically a three-phase DC output to the motor, which simulates an AC sine wave. So I'm not sure exactly what portion of the unit you're talking about, but again, AC 230 volt power to the unit itself. EXVs are 12 volt DC. The motor itself will be a VFD driven type deal, and then the ECM motor is basically the same thing as a VFD. ACN and a disassembled AC voltage reassembled into a DC three-phase, simulating the three-phase AC sine wave, if you will. So threw a lot out there because I'm not exactly sure which part you're asking about, so hopefully that answers your question.
You answered all the voltages, so I think we're covered.
All right, good deal.
I think we're good for now. There's a few other questions. I'll keep answering the easy ones on text here.
All right. All right, very good. Thanks, Ryan. So additionally in the unit now, we've got a lot of stuff going on like we had before. So we've got various fuses. So there's going to be 3 fuses on these now on the low voltage board. And as you see here, it's separated into 3 individual circuits. So fuse 1 is going to be for the PEV. And you guys remember that, that's your pressure equalization valve. So remember on some of these units, you have the PEV valve. When it shuts down, that PEV valve is energized and it balances the high side of the low side pressure. So fuse 1 is going to cover that. It's going to cover the BTM module, that's your Bluetooth module, which by the way, the Bluetooth module reports to the PCM module. So the PCM module is always monitoring the BTM module. And fuse 1 is always going to take care of the reversing valve. Okay, and these reversing valves are 24 volts DC. Okay, fuse 2 is going to be for your liquid line solenoid valve. Fuse 3 is going to be for the EXV or EXVs. So again, if you have a heat pump, you're going to have an EXV on it on the 2, 3, and 4 ton units. On the 5 ton, you're going to have 2 EXVs, one for the control of refrigerant to the outdoor coil for the heat pump, and then the second, of course, for that Braze plate heat exchanger. The PCM is just mentioned. Again, that's like the AOC board that we have on our 5-speed condensing units. This is the main board, or the motherboard, if you want to call it that. This is all the brains of the outdoor unit. So this guy is going to send the signals to the VFD or the inverter. It's going to control the condenser fan speed. It's going to control the EXVs and the vapor injection or Braze plate heat exchanger EXV. So this is going to be a busy module here. So this is going to be looking at your pressure transducers, your thermistors, monitoring all pressures, all temperatures. It's going to be monitoring motor current to the compressor, and the same thing with the condenser fan. Now, as we get further into this, we're going to find out this also has a compressor, basically operational envelope that it monitors. So it's always going to make sure that compressor is operating within a safe envelope. And by that I mean correct superheat, correct amperages, things like that. So there's a lot going on with this circuit board. We will have LEDs on it. You can kind of see the green LED here, a COM LED here, and we'll get into more explanation as we go through a couple slides here. So we're also going to monitor fault codes through this. And in a couple slides, I believe we're going to see that fault codes are going to be enunciated not only through the LEDs and flashes. You know, it's going to tell us if the board's got power, if it's in fault. And we're also going to see a display now. So you'll see the actual numeric value in this window. And as you look at this, and I believe I've got a slide that shows it, but we're going to scroll across. Because if you think about the fault codes we had before, we would have a fault code 74 or an 88 or a 24, be a 2-digit number. Now it's going to be a 4-digit number, so it'll be like a 24-88. So what you'll see if you had a 2488 is you'd see the 2 and the 4 scrolling across from right to left, and then you would see the 84 or whatever else scrolling across. So the numbers are going to scroll across this way, but then of course you read them from left to right. Okay, so, and I think I've got a decent picture of this showing one of the fault codes. So this is where you're going to pick up any kind of fault codes with sensors, as you see below, your suction pressure transducers, discharge transducers, outdoor suction thermistors, just the whole line of sensors here. So, and it'll also monitor, again, like I said, the Bluetooth module, as well as your VFD or the motor control inverter. So a lot going on there. Of course, outdoor air temperature thermistor, just like we did on 25 VNA zeros or the ANVs, the 280s. This sensor can be relocated somewhere off of the unit if you're having reading problems with the sensor. So sometimes if you're in alcoves or just installations where we've got recirculation of condenser air, solar heat gain from the sun off the siding or whatever that's affecting the OAT or outdoor air thermistor, you can relocate that. There's extra wire on it just like before, so you can move that a couple feet away if you want. But you're going to treat it the same. It works exactly the same as the other units, as well as the 5 speeds. So the OAT is going to be your thermistor that's going to report into your wall control, your infinity evolution control. That's where you're going to read your temperature from. And as well as like the outdoor coil temperature. You know, you'll have all this stuff reporting back to the wall control. So outdoor coil temperature sensor, going to be used for a couple things. One, to make sure the compressor is within its operating envelope, safe operating envelope. Also for defrost mode on the heat pumps. So, and again, that's nothing new. That's how we've been doing it for a long time. So we'll monitor out of range or air or open on the thermistors and report the fault codes back both to the user interface or wall control, as well as picking it up on the board itself on the actual fault code display here. And by the way, all the thermistors on these are 10K thermistors. Okay, so again, 10K ohm resistors. In other words, if that, I said resistor, I meant thermistor. But in other words, if that thermistor at 77 degrees, if you take the ohms reading at 77 degrees Fahrenheit, it should ohm out to 10,000 ohms. Just like a 5K, at 77 degrees Fahrenheit, it should ohm out to 5,000 ohms. Okay, so anyway, on this, we've got 10K resistors, or thermistors, I should say. Actually, they have it spelled wrong here. I just noticed that on the slide. Transducers, we've got a suction transducer, and we've got a discharge transducer, and these are just the standard 5-volt DC transducers with a 0 to 620 psi gauge range, and then just standard troubleshooting on those as well. And when I'm talking about troubleshooting here, I just got the preliminary copy of the service and troubleshooting manual. So I'm looking through that and giving some feedback to the factory on that. And we should see that book available and actually available on Partners, HVAC Partners, hopefully later next week, if not the beginning of the following. And that's going to cover all this in detail, the transducers, the misters, every component we're going through currently here. Braze plate heat exchanger, we've already talked about that, but here's a close-up picture of it. And if you're not familiar with these, basically there's multiple layers that encompass this whole area. So multiple layers are put together, stainless steel, copper, kind of sandwiched together. And then there's a cross flow for you that are familiar with HRVs or ERVs, kind of a cross flow pattern of the refrigerant through here to exchange heat. So that's what they are. The passages through them aren't real large, especially in a BPH this size. So again, as we talked yesterday in installing these, and when you're brazing the piping, you've got to purge with nitrogen. You've got to have the filter dryers in there. You've got to do that correctly, because not only are we just trying to protect the EXVs in the system, compressor windings, we're also trying to protect this device as well. So make sure you keep these systems clean when you install them, as we should on any system. So the VFD, or the inverter, or the variable frequency drive, it's called so many different names, and all at the end of the day are a VFD, variable frequency drive. Even an ECM motor is essentially a VFD. And we've had the MOC before on our other units. That's what this device is right here. So we still have capacitors in here. You can see you've got 2, 4, 6, 8 capacitors underneath here. So we're carrying a lot of voltage. On these VFDs, when they're powered, you've got, let's say, 230 volts AC going into it. Well, on the back side of it, the output power, your DC bus output power, could be 370, 380 volts DC with a lot of current. So VFDs, you've got to be extremely careful with them and making sure they're discharged before you do any type of work on them or start touching them. Now, you can go in with meter leads and measure your DC bus output voltages, but be careful. I do encourage you, I encourage any VFD that you work on, that you do wear some rated rubber gloves, and be careful. Make sure your meter leads are in good shape, and be careful, because you can really get hit with this. Now, if you're going to change one, you're going to have an LED down here, a red LED. When you turn the power off, make sure that LED extinguishes, and after it extinguishes, give it another 60 seconds before you start touching anything or taking screws off. If you watch the LED real close, you'll see after about anywhere from 3 to 5 minutes, it starts going out, and you think, hey, okay, it's completely out. If you watch it very carefully, you'll actually see it come back on just a little bit as the other final capacitors bleed down. So like I say, wait till that light extinguishes, give it another 60 seconds, then you're okay to go in and start removing wires and screws and doing whatever service that you're planning on performing. So, and that goes for every VFD out there. I don't care who the manufacturers are. I don't care what piece of equipment it is. Just know we've got a lot of capacitors in there, and they carry a lot of voltage. So be careful with them. Look at the whole control panel here. This is going to be your BTM, we're going to call it, or Bluetooth module. This is what your phone app is going to connect to. Like I say, after we get through all these components, we'll actually get into the phone app and what app it is, where you get it, all that. But this is what it's going to communicate to. So basically, we'll be able to walk up to this unit, braze it in, weigh our refrigerant charge, and start this thing up via your phone app. When you go out to service the unit, you can walk up to this unit and your phone app will attach to this Bluetooth module, and you can go in and look at your fault codes. You can see what's wrong with it. You can drive it. You can test it. Just all kinds of things. So kind of basically reduces, literally reduces the need for gauges and VOMs, meters, because we're going to be able to see what output voltages are off the inverter. Control voltages, we'll be able to see everything. And I've got some slides coming up that you'll be able to see that in action, actually. Sound blankets, there's actually 2 sound blankets on these. So you'll have the initial sound blanket and then a second sound blanket that goes over it. So again, as I said earlier, the sound levels on these are extremely low, quieter even than the 5 speeds, and the 5 speeds are pretty quiet. So, but 2 sound blankets on there, so be careful if you're taking it off for any kind of servicing, that there are 2 there. And the rotaries, the rotary compressors are brushless permanent magnet type motors. This is what they look like. So kind of a little different looking. They're Samsung compressors. They're not brand new to our industry. They've been around. You probably may have seen them in some of the VRF equipment. You know, some of the duct-free split stuff. So Samsung isn't completely new to compression. So appears to be a decent compressor, good compressor. And again, with the you know, the operating envelope algorithm that runs in the Pcm module, they're really well protected, full control over motor heat, a lot of different things. And what you'll see in this, in the operating envelope software, is you may see during cooling mode, even when it's hot out, 80, 90 degrees, you may see the condenser fan actually stop and then restart again, and stop and restart. And that can be 100% normal because it's this operating envelope that the software is looking at and the algorithms it's running. So you could see condenser fan motors just, you know, stop and sit there for a couple minutes. That's not unusual operation. So that's something you need to be aware of. As well as the condenser fan motors may slow down in lower ambient temperatures, because we can do lower ambient operation with these as well. So we'll get into that a little bit later, more detail. Okay, so checking the compressor out. There's a couple things in here. Again, 10K thermistor, and there's charts that are in the books, in the troubleshooting book, that will give you your resistance values and temperatures for troubleshooting. You can even do some of this through the Bluetooth. So just a lot of power actually in this in the app, the phone app. Troubleshooting the compressor windings. We give you some resistances here, and if you're on a 2-ton, a 3-ton, 4-ton, 5-ton, and this gives you between T1, T2, T3, your 3 terminals. Again, remember this is a 3-phase compressor driven by that VFD, even though we're putting single-phase power to the unit. But these are your resistance values. Checking out to ground, you should be greater than 1 megohm. So all these values here will also be in the controls and troubleshooting book for you. Crankcase heater operation, standard on these, and again, will energize anytime the outdoor ambience drop below 60 degrees. And like all crankcase heaters, once the unit starts up, it will power down. And we do monitor, just like the VNA zeros and the ANV, the 280s, we do monitor crankcase temperature. It's monitoring that to see what oil temperature is, make sure viscosities are correct. So it does work in conjunction with that too. It's not just a relay turning this on and off. Pcm fan motors. Now this shouldn't be too new to you. We've got this, you know, on the zeros, and may have seen this on some of the 5 speeds. So same thing, it's ECM, pulse with modulation. Voltages you'll see, 8.9 on the 2 and 3 ton, 11.1 volts DC on the 4 and 5 tons. Again, troubleshooting and controls manual will give you resistances, these voltages, and troubleshooting help in that. So it looks like it's a pretty thorough manual, what I've read through so far. We get done early enough, I'll show you some pages in it. We just can't release it for download right now because it's still in the preliminary state. So AEM, Active Envelope Management, this is what I was talking about earlier. And the whole purpose of this, again, is to protect the compressor. So it's going to look at its operating envelope. It's going to look at its superheat through suction and discharge pressure transducers, as well as the thermistors. And it's always going to try to maintain a 10 to 12 degrees superheat range. It's going to look at discharge superheat as well. So not only are we looking at suction superheat, we'll be looking at discharge superheat. So we can really dial this thing in and adjust EXVs, condenser fan speeds, all these to just keep that compressor operating right in the sweet spot, if you will. So when you see AEM, that's Active Envelope Management that resides in the PCM module, and it's just some algorithms that run. And you know, we change change speed of condenser fan motors again, and you know, on the 5 ton, the Braze plate heat exchanger and vapor injection come into play. So a lot of things going on again with the PCM module. And again, active envelope management, that's a function or algorithms within the PCM. Looking at the PCM again, here's where you can actually see one of the fault codes. So it's the way you got to look at it, get your eyes adjusted, but this is a fault code. This part says 13, so there's your 1, there's your 3. And you'll see this scrolling again from right to left, but you'll actually read the fault code from left to right, just like you're reading a book, okay? And then again, they're 2-digit fault codes. So you'll see a 13 scroll across and a dash, and then you'll see another number scroll across to tell you exactly what's going on with what component. So a lot of different stuff. You got a status light here that can flash some fault codes. You got a comm light here that should be on and doing something. You know, flashing something. It's just, it may not be something you count, but it just needs to be on and flashing to tell you it's making, you know, it's got communication. And what the communication is the communication with the Bluetooth monitor, the communication with the inverter. So it's making sure that communication bus is active and there aren't any shorts or opens in it. So this is what it should look like when it's operating, less the fault code. If you have a fault code again, you're going to see it scroll across here, and you'll see some flashing here on your status. You can also see your 3 fuses over here and different plugs and ports. Now, one thing I want to point out on this, you see service tool right here. This was something in the silk screening that isn't set up. It's not supposed to be. There isn't a service tool that plugs into this at this time. This was just a board that was out of beta production. So what I'm hearing is that's going to be eliminated. So there's nothing to plug in here because the service tool, again, is going to be your cell phone. And it doesn't matter if it's Apple or Android. Okay. So just a little bit closer look at the PCM with an actual fault code on it. Looking at the inverter, there's your actual red LED light, and that should always be on. If it's not on, then we've either lost power to the board or there's something wrong with the board. So there's your power light, power lamp, and then here's your status and comm lights down here. Okay. If you got solid green here, it means you've got low voltage power, which is good. If you don't have green here, well, for some reason we don't have low voltage to the board. And then let me back up the slide here and go back. And if you look, there's your communication light. See how that flashes green? So there isn't any rhyme or reason to the number of flashes or speed of. It just needs to be doing something. It's got to be doing some type of flashing, which means, hey, we're communicating. So again, communicating light, 24-volt power light, and then the red LED for main power. So those are all the things we'll look for on the VFD. And again, Controls and Troubleshooting book points all this out in actually more detail than I'm even going through here. And then again, when I was talking about the communication light on the PCM module, it does the same thing. You'll see that same kind of flashing. Okay. Again, solid green light will give you a low voltage, and then we'll have the other green light flashing that will say, hey, where you have communication with PCM or with the BTM and the inverter board. And here you go. Here's where that'll be flashing, and then your status light. And again, fault code, this isn't a real good picture here, but it's still trying to show that same 13. Just the picture of it didn't come out real well. There we go, and you can kind of see the fault codes scrolling across. So let me back up again here, and we'll replay this. And in this little video clip, it's really hard to see what the numbers are, but you know, when you have it live, that's 3913, so 39-13 is what the fault code is. So that's how you're going to look at the unit to determine if you have a fault code and what it is, or you just simply go up there and you attach your phone, you attach the app to the unit, and it'll tell you there. So you really don't even have to open the panel to even look at this board to figure out what's going on. You can do it all via your phone. So, and again, we'll get to that a little bit later today. The Bluetooth monitor board, this is what it looks like. And you want to see a steady flashing red LED on it. If you go up to the unit, you try to connect with your cell phone, you can't connect. Now, this is one of the things we need to start troubleshooting. You know, does the BTM module have power to it? And, you know, are we seeing the red flashing light? So let me back up, go back so you can kind of see that. So you can see the light down here that's flashing from the underneath side of the board. Okay. All right. A lot of boards, a lot of things we just went through. Are there any questions before we move on?
Well, there are dozens and dozens and dozens of questions. Do you want me to start going through them and reading them, or do you want to? How do you want to do it?
Well, I kind of anticipated a ton of questions because we just covered a lot of ground. So why
how about I
don't
read them, and if they're ones you're planning on covering in the next hour anyway, you just shelve them. And if they're ones we're not going to cover, go ahead and answer them. Let's do it that way.
Sounds like a plan.
All right. Andrew asks, how do we determine what stage the unit is in at the moment?
You can do that two ways, from the Bluetooth monitor through your cell phone or the wall control.
And for those who don't know, on the wall control, you hold the little service hat button for 10 seconds and you get into all the advanced settings, including the current operating status.
Right.
Jesse asks, will Supply House have 2 and 4 amp fuses in stock since they're not very common?
Well, what we do is we have a critical component list that we get with every new piece of equipment. And the intent is that the supply houses have at least a couple of supply houses have every critical component. So those fuses would fall into that category as a critical component because they are something different than the standard 3 and 5s.
Andrew asked if it'll change the Hertz ratings, but I don't remember what was being spoken when he mentioned that question.
The unit itself is a 60 cycle unit, and the inverter will ramp the compressor up from 0 hertz to 60 hertz. You can't overspeed these. We don't have that access into the inverter. So let's hope that answers the question.
Mark asks if the motherboard will be in stock when the units are released in June.
Same answer as the fuses. That's the intent through the critical parts list.
Jerry asks if the transducers are AC or DC.
5 volts DC.
Sergio asks, will there be a code telling you when to replace a sensor? Or is there like an error code related to the sensors?
Yes, and I'll show you the list of error codes. So yeah, if you have a transducer out of range or open or shorted, same thing with the transducer. That will turn into a fault code that can be retrieved via the BTM module on your cell phone, or again from the wall control and the service menus.
All right. Antonio asks, what temp is considered low ambient to not allow cooling mode to energize?
Well, you still have the temperatures you can set it up for on your wall control. If you want to set your lockout temperature at 55, 50, whatever, but these do have the capability to run down to low ambient operation because it will control the speed of the condenser fan to maintain head pressure and ultimately suction pressure.
And if I'm going off memory, these will go down to 0 for low ambient?
Yes.
So 0 unless you choose to limit it at the wall control to 45, 50, or 55.
Right. And also, if you're in a windy area, don't forget, if you're in a windy area, we have to think about wind baffles. So, and typically, anytime you have constant wind speeds of 5 miles per hour or above is what the criteria is for wind baffles on all product, at least all product that require wind baffles.
Right, and if you're doing low ambient, it's probably not on a regular house. It's probably on a top of an apartment building or something, and you probably do have the wind deal going on.
Right.
Andrew asks, what's the minimum temperature, outdoor temperature you can charge this at?
Well, when we talked about charging yesterday, we talked about weigh-in method. So as long as you have a warm enough coat, you can weigh it in at 0 or any temperature you want. That's the recommendation of how to charge these, is a weigh-in charge.
All right, so charging via weigh-in, temperature is irrelevant. If you wanted to check your charge with it operating, then you'd need it to be a day with a load.
So there will be a heat pump charging check chart in the troubleshooting book, but like all heat pump charge check charts, they're not for charging the unit. They're to see if it's operating within a decent envelope for that particular unit. There will ultimately be subcooling charging charts in the book that you can verify operation with. So, you know, I suppose you could use the charging chart, subcooling charging chart, but like all subcooling charging, that's 60 degrees Fahrenheit or higher. Anything lower than that, you're going to be spinning your wheels and spending extra time that doesn't need to be done, and that's why we talk about weigh-in charge always.
John asks, what is the purpose of the Braze plate heat exchanger?
The purpose of the Braze plate heat exchanger, again, is to subcool the liquid refrigerant heading out to the evaporator on the 5-ton units only. On the 5-ton units, we went to a different compressor, and when we start getting up to high outdoor temperature operating ranges, in order to recover the true 5-ton capacity of the unit, we have to subcool the liquid. And again, higher outdoor temperatures means upwards of 120 degrees, 125 degrees, and we're just not going to see that in the Chicago market, at least not very often. And my 40 years that I've been messing around in that market, I've never seen temperature that high.
All right, John asks, will you be able to diagnose some of the unit issues remotely?
You to a point, yes, through the Infinity evolution control, and if the customer is tied into that and registered, I should say registered and tied in. As far as the Bluetooth portion of it, typically you got to be within 10 feet of the unit for the signal to reach. So if you're trying to do it with your phone, it's not a drive-by thing, or you can't sit out in the street unless the street happens to be 10 feet away from the unit. So that's your Bluetooth range. And then again, through the Infinity web page, you can do some troubleshooting there, provided you've got permission with the customer and it's set up that way.
All right, Tazo asks, how important is it to have power to the crankcase heater before startup in cold weather?
Just like the 5 speeds and just like the VNA and A and Vs, you could get low sump temperature on a cold day. So you may have to have that unit powered up and depending on the temperature, you could need to have it powered up for several hours. So it works just like the 5 speeds and the VNAs and the A and Vs.
Tazo asks, what voltage for the BTM board?
Well, to be powered by 24 volts AC, if you mean the power supply to it.
All right. Andrew asks, can we bypass a transducer to allow operation for the weekend?
Never. Can never bypass a transducer. The misters, the outdoor coil thermistor and the outdoor air temperature thermistor, if those are shorted or open or faulty, the unit will still run and it'll ignore the input from them. Anything else, no. If they're down, the unit's down.
All right. There's a lot more questions, but there's so many, and there's also ones that I can't really understand what they're asking. So I'm going to let you continue on, and I'm going to try to decipher a few of them.
Okay, very good. All right, if you're doing a utility curtailment or utility interface, we can still do it on this. And again, that's if, say, ComEd wants to cycle that particular grid the customer's in. They'll cycle power off to that grid for 15 minutes and then back on, go to another power grid. So this is that whole utility curtailment that's been around for quite some time now. So of course this unit is compatible with that function. Defrost intervals, these work just like the VNAs did and the 5 speeds. So you can set them up for 30 minute, 60, 90, 120 minutes, or just leave it in auto, which I recommend. Having played with these for a long time now, since this auto defrost function has come out, this algorithm, it works great. It always monitors the temperature of the outside coil. It knows what it's doing at all times, and defrost is always complete. Now, if for some reason you don't like that, or if you're down in the southern regions of our country, then you may want to look at 90 or 120 minute set points. So we're not always looking at the unit to see if it needs to go into defrost. If you use a fixed time setting in our neck of the woods, and by that I mean the TEC territory in Indiana and Michigan, Illinois, Wisconsin, I recommend the 30-minute interval. That doesn't mean the unit's going to defrost every 30 minutes. What that means is every 30 minutes, the software is going to look at the coil temperature and look at the pressures to see if they're indicating a frosted up outdoor coil. Okay, so that's what that interval means. So after 30 minutes, it doesn't need to frost. It's going to continue to run for another 30 minutes before it looks to see if it needs to frost again. In the auto mode, it knows what's going on all the time, and when it sees it needs defrosting, that's what'll happen. So you could go a couple hours and you won't see anything for defrost in auto mode. And like I say, we've got a pretty good track record of this function now, and it works real well. So really in the TEC territories, auto, and if you don't want to do that, go to 30 minutes only. Don't get up to 60, 90, or 120 because you can get into some incomplete defrost cycles, and little by little it'll slowly ice the coil over, then you're going to have to manually defrost it. Okay, so back to the PCM module. The PCM module does have a model plug, just like the communicating furnace boards do. So if you lose a PCM module, don't forget to unplug the model plug on the failed board and plug that model plug into the new replacement board. So in the controls and troubleshooting book, you'll have the model plug numbers. And again, you'll also have the resistances for the model plugs, just like on the furnaces. It looks the same, it does the same thing. So if you happen to have this model plug, if you measure between pins 1 and 4, it'd be 5.1 k ohm. Between pins 2 and 3, 91 k. Everything works the same. And again, the model plug is just that little 1 1/4 inch by a 1 1/4 inch circuit board that have 2 surface mounted resistors on them. That's all they are. So in a pinch, you could look into the book if you had a failed model plug, say one of the resistors burnt and failed. You could, in fact, go get a couple resistors as long as they equal this resistance and plug them into those pins temporarily until you got a replacement model plug. And that was the whole purpose of giving these charts in the books over the years. Okay, and also to double check and troubleshoot the model plug. So if you get funky operation, even on a furnace, if your blower, if you're not getting the CFMs you're thinking you should, and just not working right, you check everything else out. Don't forget to unplug the model plug with the power off. So make sure you power the unit down and then take the model plug out. Measure the resistance of the resistors, and you may find that one's out of range. You may find that one's open. So that in itself can cause a lot of erratic operation. So that's the whole purpose of these charts. So the whole deal and troubleshooting on it is just what we've done before on the furnace circuit boards and other outdoor equipment with model plugs. And again, as it says down here, replacement boards don't come with a model and serial number information. So if the factory control board fails, a model plug has got to be in place in order to recognize a board. And at that point, if you replace a board, it's just like it was before in the furnaces. So let's say we've got a furnace, everything's fine, it runs along. You did the initial startup, the Infinity Evolution Control uploads the model and serial number from that board, and then we lose the board. Well, the Infinity Evolution Control will hang on to that model and serial number for you. You can replace the board and put the model plug on and you'll be just fine. Now, if you had a failed furnace board and you replaced it, put the model plug back in it, and then you lose the wall control, when you put the new wall control on, it's not going to upload the model and serial number from this replacement board. It will only look at the model plug and say, well, you got an 80,000 BTU furnace, or you've got a 3-ton outdoor unit or a 4-ton outdoor unit. You'll no longer get model and serial. The reason is, think about every single unit produced and every different serial number you're going to have for every model number. It would just be a nightmare to try to stock that many different circuit boards for every model and serial unit. Okay, so that's why it all works that way. And currently we don't have any type of software to re-download a model and serial once it's been erased or lost from a wall control change. Okay, so that's everything I think you need to know on a model plug. High pressure switches, or high pressure protection, we should say. So a couple things. If we sense high pressure, we're going to do a few things. Well, we may de-energize the VFD, wait till a discharge pressure drops below 425 pounds PSI gauge. We may ultimately, if we have high pressure protection issues, we may limit the capacity of the machine to 25% or less. So they have some type of cooling. So this thing is going to do everything it can to maintain some type of cooling in the event of a high pressure event. But you may end up locking, the system may end up locking out. If it does, it will try again after 4 hours, and it will just keep cycling here. So if you got a unit packed with cottonwood or whatever the case may be, lost a condenser fan motor or the output to it, which will also be picked up through a fault code, it's going to try to give you some cooling. So again, all these bullet points on how it responds to high pressure, that will be in the troubleshooting and controls manual when you receive the unit. And again, that should be posted to HVAC partners within the next week to week and a half. Low pressure protection. Same kind of thing. It's going to maintain and watch your suction pressure and see what's going on there. Remember, we talked about the operating envelope of the compressor. So if we see low pressure, if we see low superheats, things like that, anything that's going to cause low suction pressure, it's going to shut the unit down, and it'll watch for 2 hours in this case, and may lock out for 4 hours, and then recycle. So just a typical low pressure protection algorithm that's based off the suction pressure transducers, just like the high pressure protection is based off the discharge pressure transducers, and also looking at thermistors. So that's call it a 20,000 foot flyover of the components of the unit. Ryan, why don't we open it back up to questions?
All right. Jim asks, on utility curtailment, how do we know how to set it up?
Well, so the utility, ComEd or AEP, wherever you're at, they're going to come out and they're going to have a device that they operate. They're going to have a relay, basically, they operate, and then they have a 2-wire, normally closed circuit that goes onto the 2 utility curtailment terminals of the Pcm module. So they take care of everything, basically. They come out and mount their device that they can control remotely, and it's just a 2-wire connection to our Pcm module, just like it was a 2-wire connection to the AOC module. So, and what they do, again, so they look at different grids, and a grid may be several city blocks, and they basically energize these relays, which opens up that circuit. And of course, now you have to go into the user interface, or the Infinity Evolution Control, whatever you want to call it. You have to tell it it's got utility curtailment for this to work. But when it sees that circuit open, because they're driving the relay open, it will shut the unit down. And typically they do that for 15 minutes. So they'll shut a couple square blocks of area down for 15 minutes. And then after that, they re-energize the units, and then they move over to a couple other blocks here and there. So it's little like a rolling blackout, if you will, of condensing units. So yeah, it's just wire connection, and the utility people typically take care of all that.
When you set it up on the Infinity Stat, you can choose to have it shut down the unit, run the unit only in low capacity, or to completely ignore the utility signal and do absolutely nothing.
Exactly. Yep.
When the utility wires it up, they're just breaking low voltage power. You want to change that after they leave and wire it to the UTIL terminal on the outdoor unit. Otherwise, your customer is going to get alarms that your condensing unit's no longer communicating, because it'll be dead for power. So you don't want that to happen. You want the message the customer gets emailed to them from Infinity to say that utility shut their unit off, not that their unit has no power. And that
correct
confusion. I've been on that program. This will be my 7th summer on that program for ComEd, and they've only shut my unit off a grand total of 4 times, 8 hours total. So they give you $40 a summer to do that. It's pretty low effort in that regard.
That's what they're paying. So $40 off your electric bill.
Yeah, it's $10 a month for 4 summer months.
No, that's not bad.
Yeah, it's considering they hardly ever turned it off, and they leave you a voicemail before they do it 2 hours beforehand. So if you happen to be home, which we never really are, you just jack your stat down and pretty cool it.
Yeah, makes sense. All right.
Tazo asks, what's the highest pressure for pressure check of leaks on this unit?
I would, okay, so that's always a kind of a different question, a loaded question. So I would recommend testing your piping and testing for leaks at about 350 to 400 PSI gauge. The actual pressure test at the factory for piping, tubing, coils, and all that are upwards of 800 to 1,000 PSI gauge. But for leak testing, so there's a pressure test rating number, and then there's actually a leak test pressure for the field. And again, for the field, I'd say 350 to 400 PSI gauge is you know, the good range. That's typical range everybody uses and what's recommended.
All right. Adrian asks, can we buy plugs? I'm assuming he's talking about the model plugs.
That would be my assumption, and yes, you can.
And one more. Ferris asks, after a sealed system repair, what is the best way you recommend to charge the system?
Weigh the charge in.
In other words, take the charge out and then weigh it back in.
If the charge is okay, if it's a burnout, if you've got any kind of severe burnout, then I wouldn't put that charge back in because it's going to carry possibly some of the contaminated oil. So if it's a burnout, I would put in new refrigerant with the replacement compressor if it's a compressor fail.
Okay. All right, we're pretty much caught up for the most part, I think.
All right, good deal. All right. So let's talk about this new Bluetooth servicing startup. So a lot of different possibilities here. As you can see, Bluetooth connectivity with the BTM module. You can go right to the diagnostics and the fault codes. There's 130 plus diagnostic codes that we can grab out of this unit just through your cell phone. There's interactive troubleshooting, which we'll show here. And then we'll show some of these new fault codes. And then I'll also try to bring up, I think, Ryan, we're good to bring up a PDF after this.
Yep, you can bring it up on your screen. Yep.
Okay, good deal. I'll bring that up and show you some of these fault codes then. So the first thing we want to do is get the service app. So I don't know how many of you mess around with the apps on the phone, but there's a carrier service app that comes up out of the Apple App Store or your Android store, but you want to bring up the carrier service app. So it's called Service Tech, Carrier Service Tech, and I'll show you a picture of the icon here in a little bit. But if you bring this up, download it. Now, if we go up to the machine and you open up that app, this is what it's going to look like. And what we do is we type in the serial and model number right here. You can see that little bar right there. So type in serial and model, and then you hit basically you hit the lookup button, and it will start looking for that serial and model for you. Again, you got to be within 10 feet of the unit. Don't wander off past 10 foot of the unit while you're doing this. Should stay right next to it. The other possibility is search by barcode. So you can search by barcode, hit scan your phone over the barcode on the side of the unit, which is all on the model and serial tag. So you've got a lot of different things here. And then you go down here, and here's where you connect to equipment. Okay, so we scan, we search, then we connect to equipment, and then you're all set to go. At that point, then we can look at all kinds of pressures, temperatures, fault codes, everything else we'll see here going forward. So basically, it's going to bring up the service manual information. It's all in the app. And so it essentially eliminates having to look at all the fault codes on the PCM module, but you can do it in conjunction with it. And here are some of the codes. We're going to get back to that app here in just a little bit. Okay, but here's an example of some of the codes. So instead of having the 2-digit, now we've got 4 digits. So you could have a 31-11, as you can see here, high pressure limit fault. And on the app, it's actually going to spell out what's going on with it. It's not just going to come up, oh, you got a code 3111, now you have to resource the manual. It's not how it works. It's actually going to tell you what's going on. It'll say code 3111, compressor high pressure limit, or code 3511, compressor high compression limit fault. Just all different types of fault codes here. Again, 130 plus. So multiple different fault codes. Now, it's kind of tough doing this via this webinar. We'll be getting some of these units in Melrose Park, and we're going to install them in our lab. And then that's when we'll have some hands-on classes coming up, which may be towards this fall. I don't anticipate seeing these right now as things are going, that these hands-on classes will be available this spring yet. So, but definitely this fall, we'll go ahead and run them. I know it's AC in the fall, but we'll do the AC heat pump side hands-on so we can actually play with these and connect your phones to them. Okay. So multiple different codes. You can see an 8215 VFD shutdown with power dropout fault. Just a lot of different things. Then it'll take you. Now this is essentially looking at your cell phone. It's going to take you through this fault code decision tree. So, and it's going to give you a yes, no button to ask or press on your phone or touch. So, to tell you to turn the power off and remove control box panel, then you touch yes, and then it's going to tell you the next step. So it's actually going to take you through this step by step via your cell phone as you're standing by the unit. So here's that Carrier Service Technician app. This is what it looks like. That's the icon for it. And again, Google Play or the App Store is where you're going to find it. You'll have obviously the Bryant or the Carrier. Both apps work identical. It's just all a matter of Carrier branded, Bryant branded, but everything else does the same exact thing. And here's where we're looking at the unit, at the parameters, and hopefully you can see it on your screen well, but you can see here that it tells us our line voltage is 237 volts. AC line current is 0 at the time, meaning probably the unit isn't running. Your DC bus voltage off the inverter, 329 volts DC. Temperature, just all kinds of internal protection module temperature, just all kinds of things in here. So air conditioner cooling, 100%. So actually this is kind of faulty. If we were running at 100%, then our AC line current wouldn't be at 0 amps, but this is just a slide trying to show you what's in there, but you'll have everything. You'll have low ambient cooling. In this case, it's saying on. Curtailment right here is off. So you kind of get the picture of the different screens and what it'll show you. And there's more than just this. So you'll be able to scroll through a lot of this, looking at the different parameters. Okay. So again, yes, you can look at pressure transducers. Yes, we can look at the thermistors. You can look at everything on this and troubleshoot it. You'll get the outdoor unit fault codes, just all kinds of things here. Now, here's the caveat to using this app. Anybody can go in to Google Play or Apple and download the app, but it's not going to do you any good unless you've got an HVAC Partners account, because the account ID is what you're going to need to unlock the app when you're at a unit. Okay, so if you are a Carrier dealer, then you should have, if not somebody or somebody's in your company will have the HVAC Partners account, and you'll need to get that ID from them in order for this to work. Okay. And then obviously if the tech leaves the company, the access code will be terminated and changed. So, but all FAD, all FAD dealers have the HVAC Partners account, as well as program dealers will have an HVAC account. So you're going to need that account number in order for this app to work. Okay, that's the one caveat to it. So again, how to pair. We showed the screen on that. You open the tech app, locate the equipment, and if you haven't been paired to it before, it'll display as new equipment. Select the unit, and then you pair. And again, we talked about via barcode, serial or model number, and then connect to equipment. Okay, so it's just that simple. Okay, and then it'll bring up, different options here. So we can do interactive troubleshooting, connect to Bluetooth equipment, diagnostic literature. If you go to this, what it's doing is bringing up that troubleshooting manual that's going to be available. So a lot of different stuff here. You can also view the parts for it, installation instructions, just all kinds of things from this app. Okay, it's not a brand new app. This app's been around now for about a year, but this portion of it, being able to connect to this unit, is brand new with this particular model that's coming out. Okay, so if you say, hey, I've already got that app, great. Now it's got a new interactive portion to it. And again, you're going to have to enter your access, your HVAC Partners access account number. Once you're connected, it'll show it here is connected, show it in green, and then you can go to faults, you can go to system, you can look at the firmware updates, and then we'll talk about that. I might as well talk about that now. So on a brand new startup, remember yesterday we talked about this, that the first thing we want to do is go to the indoor control, the user interface control, or Infinity Evolution control, whatever you want to refer to it as. You want to go to that and make sure you're updated to version 3 software. Now once that's done, we go through the whole installation procedures we talked about. Now we're ready to rock and roll, start the unit up. Okay, and that's where now you connect with your app on the phone, and we want to go to firmware. And once we're connected to this and it looks at the model and serial, it's going to let you know if there's some firmware updates to the PCM module outdoors. Okay, so that's the next step in starting this up before we say, okay, let's go to cooling and check everything out, is we want to look at the firmware outside to see if there's any updates for that. If there is, then you want to go ahead and select firmware update, and then it's going to give you different information here. Okay, I'm doing a firmware update. It's going to say make sure you stay within 10 feet of the equipment, don't exit the app, and it will give you a countdown of how long it's taking to do the install firmware. It's and also showing you a bar graph on your firmware updates and where you're at there. Okay, so it gives you all kinds of information telling you what's going on. And again, don't say, yeah, okay, let's update the firmware, and you see it starting to update the firmware, and you think, well, I might as well put my vac pump away and walk away away from the unit with this, with your phone in the pocket. You're going to fail the update. Okay, so again, 10 feet from the unit while you're doing it. Once it's completed and the firmware is updated, then you're going to see the update successful, and you'll go back to connect, connected status, and then you'll be able to go into the system, start it up, watch it run, watch your pressures, just take a look at everything, and you can sit there and record all this from right there as far as doing your startup paperwork. Okay. Probably should at that point, we got 15 minutes to go. Let's go ahead and we got any questions on that, Ryan?
All right, we do have several app-related questions. First one, Andrew asks, if you don't have a cell signal, can you still use the app to troubleshoot the unit?
No.
So
Now
in
you
that
got to
case-
have a
go ahead.
we got to have a signal on some of the downloads of firmwares because some of the firmware may be pushed to the app. Okay, so the firmware could be a problem. As far as a cell signal and troubleshooting, no, or getting into the system. But firmware updates, that firmware isn't going to be on your phone, so you will need a cell phone signal for firmware updates.
And I believe that eventually the Infinity Evolution stat is also supposed to be able to push firmware updates to the outdoor unit, but not yet.
Right.
That's
Yeah,
what
that's
they
why
mentioned to me
you
as a
want to
solution
talk
for
about
places
that.
that don't have internet access, cellular access.
Yeah, I didn't even want to talk about that because that's so far out and there's so many conversations going on that I don't know when that's going to happen.
I guess in a pinch, if you were in some weird rural area that had no cell service and you needed to do it, then what you would need to do is get your phone onto Wi-Fi to get your internet access that way to the phone. And then
Yeah, you could do that.
way. So you'd have a way to do it if you had to.
Right, if the customer had a Wi-Fi that you could jump on.
Chris asks, will the service app work if you change the board since it will no longer have a model and serial number?
Yes, you'll still be able to connect to the Bluetooth module with a new PCM.
Adrian asks, can we connect 2 phones or more?
At the same time, I don't know. Again, this is brand new, haven't tried that, so I don't have an answer to that
I
question.
would bet you probably can't because none of my other Bluetooth things in my life can handle 2 connections at once. Like I can't do 2 phones to my car simultaneously. I mean, I could do one like mine and then switch to my wife, but I can't do 2 simultaneously.
Right, yeah.
So most speakers are the same way, so probably not.
Probably, yeah, most likely not.
Can you use the Carrier app for Bryant equipment and vice versa?
Yes. That was asked on one of the webinars I was on, and the answer was yes on that.
Andrew asks if you can default the firmware to another time. I assume it means update the firmware later.
No, because you got to reconnect, so you can't say update the firmware at a later time if you're not there. You have to be there with your cell phone.
So Jim asks if updates are done at the condenser or at the thermostat, and the answer would be both for that.
Right.
You're updating the condenser with the app at the condenser, and you're updating the thermostat through Wi-Fi at the thermostat.
Correct, for right now.
I'm not sure what Terry's asking here. He's saying if the update is interrupted, can you quote unquote brick the unit? I don't know what brick.
Well, it won't break the unit. It will just give you a update firmware failure, and then you start over. So it's not going to break the unit. But if, what we don't know yet is if you got, partially to a firmware update, and for some reason you got far enough through it where it didn't give you a failure. I don't know if that can even happen on this yet because we don't have enough experience on it. And then you walk away from it. I don't know if something like that could happen, but what would happen is, what I know for sure is if you walked away during a firmware update, we know for a fact you get a failure, so it should default back to the original firmware, which may not work right. That's the whole purpose of the updates, right? So if you walk away and don't update the firmware, then the unit may not function right. So it's a brand new piece of equipment, it's brand new technology. So there may be several firmware updates as we go. And if you've worked with Infinity Evolution over the years, we've had many updates, and that's why they actually push them, over the air a lot of times to the customers' homes if they're tied in.
Yeah, to Doug's point, we are probably a couple months premature on training on this, but we figured why not get a head start with it and do a web thing on it, but we won't have these units physically in place. We won't have any to play with for a few weeks, and then you won't start seeing them in the field for a couple months.
Right.
We do have several questions that are not app related if you want me to ask those now.
Sure.
All right, Jim asks, will the heat exchanger plate work in the heating mode?
No, it's a for cooling performance enhancement. Well, oh, yes, I'm sorry, yes, it will, because, yes, it will work in the heating mode. in the heat pump mode, yes. That's what you're talking about, the heat pump mode, I'm assuming.
Yeah, I think he's asking if that refrigerant pathway is still going to flow through that braze plate heat exchanger in both modes.
Yes, yeah, heat pump mode and cooling mode.
So Adrian asks if there's no way to measure the line set distance, what's the next step to charge the system?
I don't understand why you couldn't do that. There should be some way to measure the distance. You know, this is a brand new installation on this. So there should be some way to measure it. If not, then you're going to have to wait till the 65 at least, if not 70-degree outdoor ambient day, and then try to go off the subcooling charts.
Even then, I think I would estimate the distance and then put that in, weigh that in, and then tweak it by actually, traditional charging.
Well, I don't know. It depends. If you've got buried pipe in the walls and stuff, you could be way off, and these aren't big units. I mean,
it could be. I guess I'm just optimistically hoping there's not like 75 extra turns in the wall, but you never know.
Yeah, no.
Mistake and it goes this distance. I'm like, I could probably eyeball it, at least get close.
No, close isn't good when you're dealing with equipment this small, 5 ton and under. You can be way off on them.
I think the stat only lets you put in divisible by 5 feet anyway. So you couldn't even put like 29 feet in. You can only put 25 or 30. You gotta.
Yeah. So, but weigh in whenever possible. If not, you have to use a subcooling chart when outdoor conditions are suitable for it.
Okay. And Andrew asks if it is 12.00, do I have to update at that time, or can I fix it now and come back for the update?
12.00.
That is.
Well, I think that kind of tags back to what we talked about. If you have a failed firmware update for whatever reason, as long as the current firmware is operating correctly, you could come back and update at a later time. But if for some reason there was a firmware that comes out that doesn't allow the unit to operate correctly, well, then you're leaving the customer without 100% functionality of the equipment.
He's clarifying that 12.00 meant midnight on an emergency call. We just send it.
Well, yeah, you come back and do it at a later time, but if the unit was installed, it should have had firmware updates that were functional at that time. So if you're out there at midnight 5 weeks later, it still should be functional. I wouldn't think you'd be pushing updates on an emergency call like that, but yes, you could come back at a later time.
On a related note, Jim asks, how long do the updates usually take?
Well, I don't know because we haven't done any yet, but everything indicates in here they're like 5-minute updates. Thinking about the updates on Infinity Evolution over the years, 5 minutes. I've seen some maybe a little longer over the years, but I would say 10 minutes or less to be safe.
Yeah, plus it's depending on your download speed available to you as well.
Yep.
Milos is asking for data on capacity correction factors due to line set length and elevation differences.
That will be in the installation books when those come out. So they'll give you your 0 to 50 feet, your 50 to 100, et cetera, out to 250 feet. And it will give you your capacity loss based off your suction pipe size.
Andrew asks, if there's a power generator present and you have dirty electricity, do you need to install a power surge protector?
Well, a surge protector isn't going to help dirty power. That's just going to help if you have surges and hopefully keep it from damaging the motors and the equipment. Still haven't heard if in fact these have been tested on generator at this point. We went through that with variable speed equipment as far as furnaces go, and we've had some good results and not so good results depending on the the cleanliness of the power coming out. My guess is we'll have the same exact thing here, especially since we have an inverter on board. Inverters are very sensitive to supply power. So if we've got some goofy stuff coming off a generator, or generator's not grounded properly, you know, we could have problems with unit operation. Ultimately, you'll end up in fault codes and the unit will shut down.
All right, Don asks, at what temperature does the heat exchanger become operational in heat pump operation?
They don't have that info. We asked that question. We don't have that info yet when that engages. Great question. Don't have an answer to that one yet on the heat pump side. On the cooling side, we know it's around 115, 120 degrees.
All right. Jim asks, do we need to check for updates on clean-in checks? I'm assuming he means firmware updates for the condensing unit.
Sure. Yeah, absolutely. Why wouldn't you? I would always do that.
I would do the same on the thermostats. I do that now.
Yeah, I would do the same thing on the user interface. Absolutely.
Darren asks, oh, go ahead.
No, I was just going to say that's the update, something that could run while you're doing other, performing other parts of the maintenance or checkup.
Yeah, a lot of the guys, when I talk to them, there's like two schools of thought. It's working fine now. Don't do the update because then who knows what's going to change. And the other school of thought is always do the update, always have the most current thing.
Well, 99 and 9/10 of the time, the updates fix something without breaking something else. I always do an update.
What I do on my phone is when it asks me if I want to do the update, I ignore it for like a week and wait to see if anybody I know says the shit hit the fan. And if they do, then I just don't do the update until the next correction comes out. And if everything was cool for everybody else, then I'll let mine go. Yeah.
Well, typically the updates on these, though, I mean, these, you know, it's a little bit different on these, you know, with furnaces and condensers like this. It's pretty straightforward, simple fixes, usually temperature pressure ranges or time delays or something like that. So it's, I would always say yes, update it.
Yeah. Especially at the newer side of a product. When a product's in its first year or so, a lot of the fixes, a lot of the updates are related to fixing things that weren't working perfectly. Right. By the time it's on like year 7 or 8, any updates are usually feature enhancements, so that's not as critical. But at the beginning, it's usually fixing a problem that you just haven't seen yet.
Absolutely. Yep.
Darren asks, when we're using an existing line set, do you recommend an R11 flush?
You know, depending on the age, yes. Cleanliness is everything. We still go by the fact that we want less than 5% mineral oil left in the system. Older systems, even if it isn't a burnout, we can still get some kind of wax contamination and other things from the oil breakdown. So, yeah, we want, if you're going to reuse pipe, we need to look for any kind of low spots and cut those out, because those could be trapping oil. And yeah, we want to clean it up as good as possible. And R11 Flush is proved to be you know, a pretty decent product. So yeah, I would say absolutely. Let's clean it up.
Ferris asks, what is the special design feature of the evaporator coil used in this unit that we don't see with other evaporator coils?
It's the same evaporator. We haven't changed the evaporator coil. So our current product line is what we use on these. So no change to the evaporator coils. As far as installation and practices you need to make sure of, I would always, as you unbox them, I would always take a look at the distributor tubes. You may have to move those around a little bit, make sure they're not rubbing on the plate for the frame of the evaporator coil itself. You know, just kind of look at its general condition, make sure your sensing bulb is mounted tight, those type of things. But there isn't a special or specific evaporator that's been produced for this.
Andrew asks, what are the warranties if a generator takes out one of the boards?
Well, if it's proved that the generator took the board out on one of these, then they're not going to warranty the board. Well, that's we've got something goofy with the generator and we're supplying bad power to the unit. It's not the fault of the unit, so it could, I'm not saying it will, but it could void warranty on the component that failed. So make sure your generator is connected right. Make sure you've got enough generator there to drive the unit, and make sure it's grounded and you've got clean power coming out.
I think
And when you put generators in, you got to look at your total load on the generator. What's the total possible load? You know, some people say, well, I'm just going to turn the lights on in the kitchen living room and just use my refrigerator. Well, the next thing you know, they're doing a load of laundry, they got an electric dryer, they start doing all these other things. It's actually taxing the total output of the generator, and now all of a sudden this unit tries to start. Fortunately, this unit's smart enough to catch power supply issues and should shut itself down. But you know, make sure you do the right thing with the generator, and make sure it can handle everything.
All right, I think we got the bulk of these questions taken care of. Is there anything else you needed to show, Doug?
Yeah, let me drop this real quick. And just wanted to show some of the things that are in the service manual. What do we have for time, Ryan? Where are we sitting? How we're right at?
We are actually out of time, but if anybody wants to hang out for another 5-10 minutes, I'm going to sit down and watch this personally. So you guys are welcome.
Yeah, it won't take much time. So this is fault code list. Knowing the fault code, when you see 2 digits, you have a base fault code number. Like in this case, the base fault code number is 14. The actual fault is a 94. So that would mean line voltage is low, which could be this generator issue we're talking about. Base fault is 15. The actual fault's 94. It's too high. So you can see how you've got 2 numbers here of what's going on with the fault code. So as that scrolls across that little LED screen, make sure you get both numbers. And remember, you read it left to right, even though it's scrolling right to left. Okay, so these are all your fault codes. Just going through here, there's a full explanation of every fault code, suggestions for correction. Okay, so there's a lot of information, and this can be brought up on your app as you're working on this. So you get into the unit, it says, hey, you know what, we got a fault code, you know, 8833. It's a VFD internal fault. What's going on? Well, you can go through, as I showed you, the step-by-step troubleshooting, kind of follow the bouncing ball, if you will, through the app, or you can also pull up the service manual through the app and look this stuff up. So a lot of information on fault codes in here. Goes on and on. Remember, again, you know, 130 plus codes. And as I said, this is a preliminary controls and troubleshooting book right now, so it's not ready for release. Otherwise, I'd have Ryan post it so you can download it. But unfortunately, we can't do that with a preliminary book. Okay, so lots of fault codes that are in here. We'll get out of these. You can see they kind of go on and on and on. So you get past fault codes, and then you get into other stuff. Talk about the Bluetooth module, communication errors, different things with the ECM fan motor. These are where you take the ECM fan motor. If you got faults with it, it'll give you your resistance values, how to troubleshoot it. So most of you, if you're Bryant carrier people, you've seen these fault code manuals before, troubleshooting manuals before, where they cover everything. So they talk about the variable speed compressor, and its resistances, how to check it out. So just absolutely covers everything. You know, you discharge thermistors, a little bit of everything. Your OATs, I'll just let this scroll through here. Pressure transducers, suction thermistors. You can see this okay, correct, Ryan?
Yes, we can see it.
Okay, all right, good. So just all that, it'll tell you, you know, what type of thermistor it is. It's a 10K, what's going on. So high pressure switch protection. It doesn't give you here, I don't see what the high pressure is, but I can tell you it's 610. resets below 425. Just on and on and on. There's your model plugs, low pressure protection. So you can kind of see that there's just a little bit of everything in the book here. So system comm errors, give you a different EXV troubleshooting, how it's wired, the pinouts of them. So information there. The EXV, the 43 to 49 ohms, that's in the book here. You know, a lot of info, wiring diagrams, things like that. So, you know, let's see where the EXVs are connected. It'll show the wiring for that. You know, if it's a heat pump, you got the heating EXV, or if it's a 5-ton, you got the vapor injection EXV. Just all that, where your sensors are connected. So a lot of information. And again, the model plug info is on the schematic. We do very similar things with the furnaces. Defrost information. It'll take you through all the defrost routines. All right, too many emails here.
Yeah, when you're in PowerPoint, it's smart enough to mute all your email notifications, but when you're on a regular document, your computer just resumes normal behavior.
Yeah, I think my email's broke because I get one like about every 30 seconds. So I don't know if that's right or not. I'm trying to figure out a way.
Not right, but it's not broke.
There's the curtailment connection. So your utility connections right here and here. And again, this portion's done by the utility people themselves. So,
well, the utility company's not going to wire to that UTIL. You're going to have to do that. They will not do it.
Oh, is that how they're doing it now? Okay.
No, they won't do that. They won't even know what that is.
Okay.
They're gonna interrupt low voltage power, and they're gonna guess. So they're gonna just guess. They're probably gonna use red and white wire, whatever you have going out there, interrupt that, and then you're gonna have to go fix it after them.
All right. Well, you're the utility expert, so we'll go with what Ryan says there. So
I wish there was a way to like educate them on this, but it's like, you know, 1 in every 1,000 of units that they see. So.
Well, they see everybody's too, and I'm sure everybody is different. So, yeah. But anyway, you can kind of get the drift here of what's all in this in the book. So it'll talk about your comm status lights, other components in the system, low ambient cooling, crankcase heater operation. So braze plate heat exchanger, refrigerant diagram. Just a little bit of everything in here, just like always, your EXVs, everything you'd ever want to know. Alphanumeric breakdown of the model and serials. And this just happens to be the carrier book, but you know, Bryant will be the same way. Then, of course, your table of content here. So, and again, this is just a preliminary version of this. Should be completely reviewed and ready for publication here in the next week or two and post to HVAC partners. So, that's basically what I wanted to just kind of buzz through this real quick to let you see what it's about. And again, this is something that you can pick up on your app too. So you go out to the machine and you connect to it and you're telling you, okay, I got this problem. Well, you can either walk through its tutorial on how to troubleshoot it, or you can pull up the service manual on it. So a lot of support just through your phone when you're in front of the unit. So I think that's I think it's pretty cool. I think it's there may be you know, some stepping stones along the way. Maybe some software bugs. You know, we went through that with Infinity Evolution, but the good thing is the team that's working on this is, you know, it's just a very bright, it's a great team. You know, I would look for updates and stuff right away. So can't wait to start seeing this thing hit the street and getting some feedback from everybody. Any more questions?
There was one other question. It's more general. Tony asks if you have an opinion on using ProPress fittings for refrigeration. I'm not sure if he means refrigeration meaning AC units or like actual refrigeration.
No, I know exactly what he's talking about. I know some of that's coming out, but I haven't seen any jobs with it in. It's not new enough to talk about if the O-ring holds up, if the joint holds up. So jury's out for me on it. So, I'm all about brazing and permanent connections, but I'm also very much aware of how successful and how great ProPress works for chilled water piping and things like that. So it's not a bad product. The jury's out for me on refrigeration at this point. So I don't know if that answers your question or not.
And the difference being obviously refrigerants can be at a significantly higher pressure than chilled water or hot water is going to be at.
Right. It's the pressure and the connection is different. It's a little different as well. So we had at one time we were looking at a system, and we were going to do kind of pre-connections at different lengths of tubing packages, basically like we'll call it a ProPress fittings, not what it was actually called, but we looked into that. One of the other distributors out in New York was a big leader on that, and it was kind of a 50-50 outcome out of it. So, but now there's a newer system coming out from what I'm hearing, but just not enough information to comment.
All right. Jim asks a question that he asked earlier, and I thought we answered it, but maybe not because he typed it back in. He wants to know if we need to install surge protectors, and if so, any recommendations?
Well, so like any VFD, there's always protection. It's always looking at the input, the incoming power supply to it. And, it's got current torids on it, voltage monitoring. So it's always looking at the input power. And if it sees something goofy or out of range, it's not going to allow the compressor or the condenser fan motors to start. So typically with a power supply problem, this unit's smart enough to see it and go into a fault rather than to allow it to operate, because you've got low voltage protection, high voltage, or I should say under voltage protection, over voltage protection, undercurrent protection, overcurrent protection. So we've got monitoring on this system that would suffice, let's say, for brownout conditions or spikes to a point. I don't know if it'd be worth hanging one of those on or not. I'm going to say no. As far as dirty power, really, I don't know what to say about that at this point. We don't know, what kind of effects it can have. There's been so many things over the years with power supply, and at one time they were using the power supplies as a communication feed as well, or they were using the L1 lead for basically a carrier wave that they were sending signal on. And back in the years ago, we found that caused problems with the ECM motors on the furnaces. So I don't know that they're doing that anymore. And if you actually had dirty power, if you will, and when I hear dirty power, to me, that's not over voltage or under voltage supply. Dirty power to me is my AC sine wave is being modulated by something, okay, some outside source. So again, unit's too new to tell if true dirty power would cause anything, and a surge arrest or a surge protection isn't going to sort out dirty power. So how is that? Did that help any?
Yep, and by me at least, I'm on ComEd. They do use the line voltage power for communication still. Specifically, okay. My smart meter is using it, and as is my load shedding. My utility curtailment is using it. There's no additional wires that go there, so it's got to be over those wires.
Right.
On the utility curtailment, there's a couple questions I'll try to help answer here. Ferris asks what happens if the utility sends a shutdown signal when their unit's in the heat cycle. That's not likely to happen because they only do these power surge shutdown things on the peak hottest days of the year when they're having problems keeping up. So it's a summertime only program. None of them do it in the winter at all.
Right.
So that would be August. You shouldn't have an issue.
Yep, that would be my thought.
And on a related note, Jim asks if the utility curtailment is wired but not set up, will that cause problems?
No.
So no, if it's wired to UTIL, but if the utility just interrupted two of your low voltage wires because they don't know that you have a communicating thing, right? You have two wires going from inside to outside. They just assume it's a Y and a C and they interrupt it. Then what will happen is when they give you the load shed signal, you'll lose power communication and you're going to get an email from your thermostat saying can't talk to your condensing unit.
Right.
So it won't be a problem. It'll stop functioning just like the program is designed to do. The problem for you will be that you'll get an email from the customer saying the unit can't talk. You'll show up out there to fix it, but it'll be 2 hours later and the event will be over and everything will look fine. You're like, what the hell, man?
Right.
Whereas if they wire it to the correct UTIL terminal, then the customer gets a different message, which is your utility turned off your unit.
Yeah. I think that a lot of these guys, if they opened this unit up, they just put the panel back on it and tell the homeowner they need to, engage with their HVAC service group or something. We get.
When you say you guys, you mean
we get calls in
or the tech? You mean the HVAC tech or the utility guy?
The utility guy. I think if some of the utility guys go out to do this, they open this up. I think some of them would refrain to tie in because we do get calls into tech support from various people on this from time to time.
The other problem though is they don't open the unit up. They just interrupt the two wires coming from outside to inside.
Yeah, well, geez, I hope they don't do that.
That's what they do. That's what they did in my house. They just snip the wire, run it into their box, and then run a new wire from their box back down to where they left off at.
Okay, well, that's a little scary.
Yeah.
It's not going to burn anything, but it will result in exactly what Ryan described.
Yeah. I mean, it still functions. It just you get the wrong message. And the wrong person gets blamed. One more question, Doug, and then we're going to shut it off here, I think. John asked, on some of the older inverters, there were issues. What has changed from the old style stuff from like 10 years ago to now?
Well, the old 25 VNA zeros or the A and V, the 280s, 280 A and Vs, this is a completely different inverter, completely redesigned different inverter. So at the end of the day, it's still an inverter. Okay. This one's been simplified, and that's about as far as I can go right now. It's been redesigned, it's been simplified. Until we get these things out in the field, that are in unusual applications or things like that. They start seeing, condenser coils plugged with cottonwood, all this kind of stuff. I don't know what's going to happen exactly, if we're going to have a bug here or there. But what I can tell you is they're completely different and redesigned from what we had. But again, at the end of the day, an inverter is an inverter. So you've got a power section, you've got a filter section, you've got a rectification section, you got an IGBT section that reassembles the power into an output. So we'll see how everything goes. I've got some confidence knowing the team that was working on this. Will we have a bug here or there? My guess is probably. What that bug will be, I don't know yet. So anytime you get into the high-end equipment, there's always a margin or area of improvement. So right now, I think, and especially with the delay of its delivery out to the field, I think that a lot of this stuff is going to be worked out right away, if there's anything at all to even work out. Okay, so I'm pretty confident in this one coming out. And again, we're probably looking at the June time frame for delivery, because we still have to, we need to push out our VNA zeros and our 280s that we have. So, and by the time we get done with that, will be about the time we start receiving our shipments in for these units. And we'll go from there. So we may not be the first kid on the block to start distributing these. Some of the other distributors probably will beat us, and probably the southern distributors down in the southeast and southwest regions. So they'll probably get a leg up on us and identify any potential issues, if any at all, and by that time we'll be geared and ready to receive equipment that's been modified or adjusted, and we'll have a leg up on it. So
yeah, so I think some of the other advantages of the new versus the old is, well, for one, carriers had inverters in general for 9 or 10 years now for residential equipment, so it's not as new to the people designing it as it was then. The other thing is that the inverter this time is made by the same company as the compressor. So you would think that they would be more helpful in being able to flush things out. But to me, the biggest thing is the new ones, if the problem is related to the software, it's field updatable. Whereas in the old ones, when we had a software issue, you had to swap out the inverter, which is just a pain for no reason. This will be a lot easier. You'll do it from the app with software update. So that should help out with some of those things if there is something that needs to be tweaked that's minor.
Yeah, now most of that update, most of the field update is going to be for the PCM module. So the inverter is just going to follow what the PCM tells it to do.
Yeah. All right, sir. Well, we are way over our time. I thank you very much, Doug, for helping out, because if I did this, it would have been a half an hour thing and it would have been pretty high level. You managed to do it for 3.5 hours, and we probably could have won another hour if we let people keep asking questions. Yeah. So I thank you very much for all the help.
You bet.
And if anybody else has further questions, hit us up and we'll try to answer them the best we can. Thank you, guys.
All right. Everybody have a great weekend and a happy Easter. Be safe.